Okay. Hi everyone. Thanks for attending this tutorial. I'm Chongro from UC Davis. I worked with Hangzheng on this project during my internship at Amazon. So in this part, I will give a hands-on tutorial for you to get familiar with our framework, AutoGround. AutoGround is a flexible framework that you can easily tune the hyperparameters automatically. You can also do model selection and architecture search. It is a general framework for image, text, and tabular data. So in this section, I'm going to briefly talk about how to use AutoGround to do hyperparameter optimization, which we call HPO. So for deep learning methods, we usually need to train models on our dataset, and different combination of hyperparameters will lead to different final performance. So in many scenarios, we need to try different combinations of hyperparameters to see which combination could lead to the better performance. So in this process, it takes a lot of effort. However, with AutoGround, you can easily do it with few lines of code. And in our tutorial, you will see our framework is flexible and easy to use. And this tutorial has two parts. The first one is how to define the search space and decorator. And the second one shows a simple example that's how we do the HPO on this dataset. So after finishing this tutorial, you will be familiar with how to incorporate AutoGround into your own work. And let's start. Before we start, we need to install the AutoGround. It is very simple. So you can just run these two commands. And for this tutorial, you need to install AutoGround first and then launch the Jupyter with the installed environment. Okay, let's move on to the first part. So in this part, we are going to talk about how to define the space, search space for the hyperparameters. We know that in the hyperparameter optimization, we need to first define the search space, and then there is a searcher which will sample from the space and train the model with the sample parameters, and we call it one trail. And we run on different trails and then get the best config that achieves the best performance. Okay, and let's first import AutoGround. And the first simple search space is integer space. And so here we define A as integer space, and we provide the boundary values. If we print A, we can see that A is integer space, and from 0 to 10. And we can randomly sample one value from this space by calling the a.rand. So if we run it, we get it return one value 5. So it is sampled from this space. And if we call it again, it will get another random value. Okay. The next one is the real space. So it is similar to the integer space, and we can define B as real space, and we can provide the lower value and the upper value. And it is also possible for us to provide the flag log. So log here means whether we sample the value on a log scale or linear scale. Okay, so the last simple search space is categorical space. So for the categorical space, we can sample one value from some provided values. So for example, here it has 3 values: Monday, Tuesday, Wednesday, and if we sample one value, we get Wednesday. So it's actually one of the 3 possible values in the definition of the categorical space. Okay. Besides the simple search space, AutoGround also supports the nested search space. One of the nested search space is listed space. So for the listed space, it lists the a search space for several hyperparameters. For example, here F is the list space, and it has the two subspaces. The first one is the integer space from 0 to 3, and the other one is the categorical space. Okay, if we call f.rand, it returns a list, and each value in this list means the sample value from the corresponding subspace. So we can see that the first value 2 is sampled from the integer space, and beta from the categorical space. Okay. So in addition to the list, we also have a dictionary. So it's very similar to the list space, but it returns a dictionary. So the value of the key actually is sampled from the corresponding subspace. So you can see that the value of the key 1 is beta, which is sampled from the categorical space, and number 1, the value 1 is from the integer space. That is for the key 2. Okay. So now we have talked about the how to define the search space, and next we will show how to use decorator to make our object and function searchable. So for example, we have defined one object, which is called myObject, and it has 3 attributes: name, rank, and a static value. And it is easy to define the search space for the 3 attributes by adding a decorator before this object. And you can see that in this decorator, we define the space for the 3 attributes. So for the name, we define, so the name is the categorical space, and static value is constant number value 10, and the rank is the integer space. Okay, if we call h.rand, it will sample one combination of this space. So here, name is sampled as the ground, and the rank is 3, and the static value is constant 10. Okay. Besides object, we can also use decorator for the general functions. So for example, here we have train function, and this function just prints the arguments, and we have the decorator to define the search space for hyperparameters in these functions. Okay, the last part is how to initialize a searcher, and how to get a possible config from this searcher. So config here means one combination of hyperparameters. Okay, let's see one example. So here's searcher is initialized as the random searcher. So in the outer ground, it provides multiple searcher: random searcher, grid searcher, and reinforced learning searcher. And so here we pass the config space of the function we define here to this random searcher. So CS means the configure space, and then we call searcher.get config to get one possible config. If we print this config, you can see, okay, so here the value of A is sampled to 6, which is sampled from the integer space from 1 to 10, and B is 0.0055, and D trace is 0. So 0 here means the index of the items in the definition of the categorical space. So you can see that D is a categorical space, and it has 4 values. So here 0 refers to the A. Okay, and then once we got the possible config, we can train our network or call other functions with this config. Oh, we need to run this first. So once we got a config, we can call the function with this config. So we pass the config to the train function, which we define here. And because this function just prints the argument, so it still prints the values in this config. Okay. Now you may still have some questions about how to use them in your code. So don't worry. Let's say a very simple example. This example is about the MNIST, which is to classify the digits in the in different images. Okay, so in this part, we will show how to do the hyperparameter optimization, HPO, using the autogram with PyTorch. So as you know, that autogram is a general framework, and it is compatible with any training code that is returned in Python. Okay, let's start. So first, we need to import the required libraries, and then we initialize the data set. Okay, and then we need to define the main training loop. So in this training loop script, okay, so in this training script, you can see that we have defined some hyperparameters like learning rate, rate decay, optimizer and train function, test function, and for loop to go over all the epochs. Okay, and then we after defining the training script, we will define the network. So here we have the simple network. This network only has two convolution layers and three fully connected layers, and there are two hyperparameters. The first one is the hidden convolution. That means the number of the channels in the convolution layers. And hidden FC represents the number of channels in the FC layers. Okay, and then in the first section, we already talked about how we can use decorator to define a space. So here we have one decorator before the definition of this net, and we define a space for these two hyperparameters. So the hidden convolution is the integer space, which is from 6 to 12, and hidden FC is a categorical space. Okay, so now we have convert this network to a searchable network by adding a decorator. Okay, so next we will convert the training script to be searchable. So here, let's run this first. So here we have already defined the train MNIST. And we can just add the decorator before the function to make the training function to be searchable. So you can see here we define a space for learning rate, rate decay, and network. So because network is a searchable network, so we need to define it here. And also we specify we set the number of epochs to 5. Okay. The next part is actually this is the last part before running the code. It is a scheduler. So there are in autogram there are a number of different schedulers, and one is FIFO scheduler. So it means that each job will run for the full number of epochs. And another is the hyperband scheduler. It means that it will stop the unpromising jobs earlier. Okay, so so in this case, we use the FIFO scheduler, and I will explain this arguments later. Okay, let's let's run this example. It may take 1 or 2 minutes, and at the same time, I will explain the arguments here. So you can see that after we run this code, there are two there are two there are two jobs. It's because that we set the number of threads to 2. So number of threads here means the maximum number of jobs that we can run, and then we can also specify the resources. And now we use 1 GPU, so it means that we can just run the job one by one. If we have the multiple GPUs, we can run the multiple jobs at the same time. Okay, and the first argument actually is the searchable function that we defined here, the ag train MNIST. And okay, and the reward one is accuracy. It means that we use the accuracy as our metric to choose which config is the best. Okay, and you can see now this is the first job. It's already finished for app house. Okay, it may take some time. And here, so the learning rate means that so it means that the sample learning rate and the sample week decay for the first job. And then it is running the second job. Still, it needs to run 5 apples because this is FIFO scheduler. And in this job, you can see that learning rate and week decay are different from the learning rate and decay and week decay in the first job, because this is because they are randomly sampled. Okay, after we finish running these 2 jobs, we will plug the curves for these 2 jobs, and we also print the best config. Means that which config has the better performance. Okay, 2 app box left. Okay, 1 left, last one. Okay, it's finished. So we can run the last part. Okay, you can see that we show the curves of 2 jobs. These 2 jobs are in these 2 jobs we train the 2 different networks with different hyperparameters. You can see that the best config is this config, and the best accuracy we can get is the 98.8. That's this one, and this is the corresponding config. So in this example, you can see that we use AutoGround to automatically choose the best config, and then you don't need to run the different configs by yourself. Okay, and there are more advanced features, and you can find them in our on our homepage, AutoGround homepage. Okay, cool. So just to ramp up, we have already talked about how to define the search space. in the autoground, and also talk about one example to do the HPO on the MNIST dataset. And hope you get familiar with autoground, and hope our framework could help you on your code. Okay, thanks.